Hi everybody, this is Mrs. Haynes and welcome to, this is an extension of the week 5. Wanted to be able to teach us when I had the computer on the screen, on the calculator on the screen so I could show you. We're going to learn how to model quadratic functions. So this is lesson 4.3. So you need to have your calculator, pencil and paper, and your algebra book open to page 211. Okay, and we're going to, so if you need to do those things, go ahead and pause it and go get them. Okay, if you're back, we're on problem 3, top of page 211. So basically, just like we did a linear regression where we took some data that looked like it followed a straight line, and we calculated a line of best fit on the calculator using regression analysis, we're going to do the same thing for a quadratic today, since chapter 4 is about quadratics. So anyway, it says the table shows a meteorologist's predicted temperatures for an October day in Sacramento, California. And what's the quadratic model for this data? You'll notice it makes sense that it follows the quadratic model because in the morning the temperature is cool. And what's going to happen, it's going to climb through the day and it's going to peak sometime in the afternoon, and then it's going to start dropping as the sun goes down. So we would expect it to be an upside down parabola. Okay, so the first thing we've got to do is we've got to make our axis. So now we're going to make the data useful before. So you don't need the calculator until you've got all your data stuff figured out. So I'm going to go to the whiteboard and make sure you have a piece of paper. And I want what I write on the screen, I want you guys to write on the screen. So we know we're going to be entering data as x and y. X is the independent variable, y is the dependent variable. And it's going to be a quadratic equation, so we're looking at ax squared plus bx, the function y equal ax squared plus bx plus c. Okay, our x data starts at 8 in the morning, 10, 12. We don't really want to write 2 because that implies, we know 2 p.m. is 2 hours after 12 a.m. But numerically, it's going to send it backward and it's going to think it's less than 8. So we have to use military time, and hopefully you guys are all familiar with military time. That's where you take it as a 24-hour clock. So 2 p.m. is really going to be 1400, 4 p.m. is 1600, and 6 p.m. is 1800. And then for our y data, this is pretty straightforward. 52 degrees, 64, 72, 78, 81, and 76. So this is the data we want to enter in our calculator. So we need to set our window so we know what screen we're looking at. So we've got a minimum x value, a maximum x value, a minimum y value, a maximum y value, and then I kind of left it off, but we're going to have x scale, which is how long, like when you have these, how long you want these little lines to be, what spacing in between them, and let me erase that. And a y scale. Okay, so x minimum, it's starting at 8 in the morning, so maybe we'll make it like 6 a.m. X max is 1800, which is 6 p.m. Maybe we'll make it 8 p.m., so we'll make it 20. And 6 to 20 is 14 spaces, so x scale equal 1. That way we'll know each one of the little tick marks is going to be 8. Y minimum, it's 52 degrees. Maybe make it, I don't know, 40 degrees. And maximum, maybe make it 90 degrees. Okay, so you're going to want to write down that information. I need to write it down because I'm not going to be able to see it in a minute. So we're going from 8 to 18, and then the other data is going to be straight from there. Our x is going to be 6 to 20 with a scale of 1. Our y is going to be 40 to 90 with the scale of 5. Okay, so we're going to input that into our calculator. Let me hop out of the screen. I'm going to share screen too. Okay, so here's your calculator screen, and just a reminder, this big square in the middle is what you see on your screen, and the smaller one on the right is what's below it. Computer screens are short and wide, so that's why I did set them side by side. So we're going to get our window set. So we're going to go to Window. X min is going to be 6. Our maximum x is going to be 20. X scale, we're going to leave it at 1. Y minimum is going to be 40 degrees. Maximum is going to be 90 degrees. And we're going to make that every 5 spaces. Okay, don't worry about the rest of it. Okay, so we've got our scale set up. Now what we've got to do is enter the data. And I learned a shortcut. I was kind of playing around with it. Learned a shortcut for clearing lists. I'm going to teach you a different way than we learned in class. I think you're going to like it. So we know we're going to be doing calculations and statistics. So we're going to stat is short for statistical analysis. So let's go ahead and make sure we've entered everything. So we'll clear out our screen to quit. Okay. So we're going to go to statistics. Edit is where you add lists and change lists. So we're going to go there. I'm going to go up here. So we want to clear out list 2. So I get it highlighted and I hit clear. And then I hit enter. And then we're going to do the same thing for list 1. So we're going to highlight the list, hit clear, and then hit enter, and that'll clear out all the data. We don't have to go to memory management. So I'm going to do this fairly quickly. So we're going to enter the data from the table. So I'm going to enter my x's and then my y's. You can do the same. I won't even talk about it. That way you can focus on doing it at your own speed. Okay, if you don't have all your data in, just pause till you get it in, but we're going to move on. So we've got it all in. So we'll hit quit. Well, back to the beginning. So now we're ready to, let's go ahead and see if our stat plot is turned on. So you need your, you just need the first plot turned on. We want our X, so let's go ahead and get it turned on. And we're going to do it in blue. Our X's are in list 1, which is where we typed them. Our Y's are in list 2. And we're going to have the marks be little squares, and our color is going to be blue. Okay. So we'll hit quit, get out of that, and let's take a look at the graph and see what it looks like. So it looks like that. So it looks like it's getting ready to follow a parabola, doesn't it? Okay. So now what we're going to do, now that we've got our data in, we've got to run an analysis on our data. So we're going to go back to statistics. And since we're running an analysis, we're going to do some calculations. So we'll go over to calculations. Now, we're not interested in the linear regression because we're not doing a straight line. We're doing a quadratic equation, the ax squared plus bx plus c. So we're going to run 5. Our x's are in list 1, our y's are in list 2. And we're ready to do some calculating. I don't want you to use that. Okay, so if y equal ax squared plus bx plus c, this is going to be our equation. So I want you to write that down on your piece of paper. Write y equal, and then just plug in these numbers. Just to be safe, go ahead and copy them all down. Don't round any of them. Don't forget the x squared and all of that. So you're going to put the coefficients in front of it. So you're going to want to keep the x squared and the x and replace the a, b, and c in that equation. Okay. If you don't have it written down, you can pause the video, but I'm going to keep going. Okay. Now what we got to do is we got to plot that parabola in our calculator. So you're going to go to y equal. Actually, let me do something real quick and show you guys something. I want to make sure you wrote what you were supposed to write. Okay, I'm going to clear all this out because I don't need any more. So this is what you should have written on your paper. Y equal negative 0.46875 x squared plus x minus, should have written smaller, so it looks something like that. Okay. Okay. So now we're going to type that in our Y1. Don't forget, do the negative sign, not the minus sign. And don't forget the x's are up here next to the alpha key. And you're going to want to square it. Okay. So it's so long, because we didn't round anything, it's going to be really long. That's okay. Okay. So we're going to enter that. Okay. And looks like it's also going to be in blue. So we're ready to graph it. I did something wrong. That's embarrassing. So that was a negative, I think. I'm going to make sure. Okay. I'm going to make sure I didn't do a oh, I've typed it in twice. So I'm going to back up to this. Typed in 2 minus signs. I don't know why. I'm going to delete one of them. Now it should be good. It's pretty good data fit, isn't it? It looks good. Okay. And so if they wanted the line of best fit, then you would write that y equal negative 0.468 blah 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 x squared plus 14.7 blah 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 x minus 36.12 blah blah blah. So that would be our line of best fit. Okay. Now suppose they said, hey, I wonder what the predicted temperature would be at 5 p.m. So I want everybody to write 5 p.m. on your paper. And if it's 5 p.m., I want you to decide what number that would be in x. So look at your data for your x scale and decide what you would use for x, for 5 p.m. for x. So if it's 5 p.m., what does x equal? Hopefully you got 17. So we want to see, hey, I wonder what our data would predict it would be at x equals 17. So we know these are by ones. So started in 6 and went to 20. So 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So it's going to be about here. Okay, so I'm going to show you a way to handle that. We're going to do a different kind of calculation that we haven't done before. So watch carefully. We're going to go to the second function. Well, first of all, at the top, do you see where it says calculate? That's where you can calculate stuff about your graph. So go to second, calculate. And the very first thing is highlighted. And what it says is, hey, if you give me an X value, I will tell you what the predicted Y value is. And that's what we want to do. It's already highlighted, so we hit enter. And at the bottom it says, hey, what do you want X to be? We want X to be 17. And we hit enter. So if X is 17, our model says our temperature is going to be 78.58 degrees. So you would write on your paper, write temperature, predicted temperature. I'm not going to go back to the whiteboard. Predicted temperature at 5 p.m. is 78.58 degrees Fahrenheit. Okay. Now what we're going to do is we're going to predict, see what our model predicts the high temperature to be. First of all, looking at your data plot and at your high temperature, looking at your data point, it looks like our graph is actually going to predict the high temperature to be lower than the actual one. But we think it's going to be around here. So this is going to be something that we've never done before. So basically, we want to predict, remember we talked about with ranges, maximum values and minimum values? Since it's an upside down parabola, it's going to have a maximum value. And we know it's going to be around here somewhere, kind of close to where that little box is. So what we're going to do is we're going to do some calculations to figure out the maximum spot on this curve. So you're going to we're going to do the calculate thing again, which is above the trace function. So go to second calculate and think about what would be a good choice. Since we want the highest point on the curve, we're going to choose maximum. If we wanted the lowest point on the curve, because it was a smiley face parabola, we would choose minimum. Okay. Now, do you see at the bottom where it says left bound question mark? We've got to scoot our cursor so that we know it's below the maximum point on the left side. So you can only move the cursor with the sideways arrow. So we're going to back it up. And you can tell when you're getting lower because the X values are dropping. But I want to be kind of close to the top, but not over the top. Okay, so that's 14.96. So I'm going to back it up a little bit. And that looks like a good place. It's close to the top, but it's not at the top on the left side. So our left bound side, we're happy with that number, so we hit enter. Now it says, hey, now you've got to get on the right side of that top point. So we're going to scoot it over, and we're going to peak, and then we got to make sure that we're dropping. Still going up. Oops, let me back up and do it again. Okay, looking at your Y, so we're at 79. Okay, and it's definitely starting to, looks like it's starting to drop a little bit. We're definitely past it because the peak was in the 79s and this is a 78. So we should be good here. Okay, so that's going to be our right bound guess. So we're going to hit enter. So the two that we chose is on the left bound. It's left of the maximum, and the other one's on the right of the maximum. Now it's saying guess. What do you think the maximum is? So let's kind of go ahead and get over where we think the maximum might be. It looks like it's going to be about here. So that's as good a guess as any. So we're going to hit enter. And I want you to notice those numbers. I want you to write them down. These we can round a little bit. So we want you to write the X max. So write X max equal 15.69 and Y, I'm sorry, not X max, just X equal 15.69, Y max equal 79.38. So I want you to copy down those numbers, both of them rounded to the nearest hundredth. Okay? I'm going to get out of this and we're going to go back to the whiteboard. Okay, so this was our equation. And let's suppose what the question said is, B says, use your model to predict the high temperature for the day. And at what time does the high temperature occur? Okay, so with the high temperature of the day is going to be the Y value. So our Y maxed out at 79.38 degrees Fahrenheit. And the time that it happened was at 15.69. Okay, so 15 is going to be, remember it's a little bit later, so 3 o'clock, so 1500 would be 3 o'clock, 1600 would be 4 o'clock. So 15, it's a little confusing because this is decimal points, but it's going to be a little over half. So you could say about 3:40 p.m. Again, we can work on how to do the time. Your homework won't involve time, so it'll be a little easier. You can just give the number. So the hottest predicted time of the day was 79.38 degrees Fahrenheit at about 3:40 p.m. Okay, that's about it. That should be enough to get you through. There's only 2 problems in that section. And if you get stuck, you can always watch the video again. If your calculator locks up and you have a quick question, just give me a call and I'll talk you through it over the phone. Other than that, I hope to see everybody on Friday at the review session. Bye. Bye, everybody.